Assalamu alaikum everyone. This is Fahad Ansari and I'm here to help you conquer chemistry. In this video we will be looking at isotopes. So let's take a look at the definition of an isotope. So isotopes are atoms of the same element with different nucleon numbers. So let's break this definition down. So it says over here atoms, and the word atom implies that we have electrically neutral particles, which means that the total positive charge and the total negative charge will be equal. So this means that the same numbers of protons and electrons will exist in these atoms. Now these are atoms of the same element. So the same element implies that isotopes are basically atoms of the same element of the same type, which means they have the same number of protons as each other. So isotopes are atoms, they have the same number of protons as each other, and they have the same number of electrons as each other. Now it says over here they have different nucleon numbers. So if they have the same numbers of protons, then what causes the difference in the nucleon numbers? Well, remember that the nucleon number is the number of protons as well as the neutrons. Now if the protons are the same, we have the same numbers of protons, then it's actually the numbers of neutrons that are different. So basically these are atoms of the same element, they have the same numbers of protons, the same numbers of electrons, but different numbers of neutrons. Now let's take a look at the comparison of their properties. Now isotopes have this different number of neutrons in each isotope. So that means there are different physical properties for each isotope. Now these physical properties include things like melting point, boiling point, density, etc. Basically all those quantities or properties that can be measured without the need of carrying out a chemical reaction. Let's take a look at chemical properties. The fact that isotopes have the same numbers of protons and electrons, and the fact that because they have the same numbers of electrons, they also have the same numbers of outer shell electrons. And it's the outer shell electrons that dictate the chemical properties. In other words, they dictate the behavior of these isotopes in their chemical reactions. So because of the fact that isotopes have the same total number of electrons, they have the same arrangement of electrons, so that means the same number of electrons in the outer shell, which dictates the behavior of these isotopes in reactions. So because of that, they have the same chemical properties to behave the same way in chemical reactions. So now let's take a look at an example. So over here we have three isotopes of the same element, carbon. So carbon, the name of the element followed by a dash followed by a 12, which is your nucleon number. Remember, we symbolize this with the letter A. All right. So over here we have two other isotopes, carbon 13 and carbon 14. Now, because these are atoms of the same element, carbon, they have the same proton number, which in fact is 6. Remember, proton number is symbolized by Z. So Z equals 6 for all three isotopes. But you can see over here that A for the first isotope is 12, for the second isotope is 13, for the third isotope it is 14. So you can see where this is going, where we look at the number of neutrons, which is basically A minus Z. the nucleon number minus the proton number. In this case, it is 12 minus 6. That gives us 6 neutrons in the first isotope. Then in the second isotope, that means 7 neutrons. And in the third, we have 8 neutrons. And remember, because these are atoms, the number of electrons will also be 6 for all 3 isotopes, because of the fact that these are electrically neutral atoms. Now you can see over here that because they have the same numbers of electrons, they have the same numbers of electrons in the outermost shell. I'll take carbon-12 as an example. They have 4 electrons each in their outer shells of the atoms of the carbon-12 isotope. And the same goes for carbon-13 and carbon-14. And because of this number of outer shell electrons, all 3 isotopes behave the same way, form the same compounds when they are subjected to the same chemical reactions. And because of the difference in the numbers of neutrons, we have 6 over here, 7 and 8 respectively. Because of this difference in the number of neutrons, which causes a difference in the number of nucleons in the nucleus of the atoms, we have different physical properties. So isotopes can be classified broadly into 2 types. We have stable isotopes and we have radioactive isotopes. Now, radioactive isotopes are those that are unstable. Their nuclei are unstable, because of which the nucleus emits certain types of radiation, such as alpha particles, beta particles, or gamma rays. Now, we're not going to go into the details of that, but it's just sufficient to know that this radiation can cause harmful effects to your health if you're exposed to it in too large a quantity for too long a time period. But these radiations also have their uses, such as in cancer treatment and in irradiating food items and in finding flaws and defects in industrial products. So this was all about isotopes, and hopefully now you can tell them apart. You can tell them apart better than these 3 Spider-Men can tell each other apart. And it's just the difference in the physical properties. Chemical properties remain the same. These are atoms of the same element, but they're different because of the numbers of neutrons. All right, so this was about isotopes. In the next video, we will be looking at the electronic configuration, basically the way in which electrons are distributed between the shells in which they reside. So I hope you enjoyed this video. If you did, please leave a like, do subscribe to the channel, and inshallah I will see you in the next video.